Boys and girls, let's take a look at this problem. When Min first measured a plant, it was 11 and 7/8 inches high. When he measured the plant a second time, he determined that the plant had grown 2 and 3/4 inches since he first measured it. What was the plant's height when Min measured it the second time? All right, so the next thing I want to do is I want to reread my problem and I want to find those important details. I want to jail my details. That means I want to circle, highlight, underline. However, you need to show that the detail is important to solving this problem. Now, I can't mark this up over here on the screen, so I'm just going to point them out and we'll go from there. So when men first measured a plant, it was 11 and 7/8 inches high. This is important to know. This is how high it was the first time he measured it, right? So I would jail this detail, 11 and 7/8 inches. When he measured the plant a second time, he determined that the plant had grown 2 and 3/4 inches since he first measured it. This is important. It had grown 2 and 3/4 inches. So I would jail this detail. Now let's decide what what they want us to answer. What operation do we need to perform to answer this question? So it says, what was the plant's height when men measured it the second time? So here it was the first time. It grew this much. What was the measurement the second time? So the operation that we need to perform is to add. We want to take where we started with the plant, add how much it had grown, and that will tell us what the height of the plant was the second time. So let's start out by writing an expression to represent this situation. So 11 and 7/8 plus 2 and 3/4. So I have to use what I know about adding mixed numbers and apply it to this problem. We've talked about how mixed numbers have a whole number part and a fraction part. And when we add them together, we want to look at the whole numbers together and the fraction parts together. So I'm going to split my problem into my whole number parts, 11 plus 2, and my fraction parts, 7/8 plus 3/4. And we're going to use what we know about adding fractions and apply it here. Now this is just personal preference. Let me get an equal sign here. I like to do the fraction part first. That way, if I need to make any adjustments, I can do that to my whole numbers. We have learned in the past that if we're adding and when we get an improper fraction, sometimes we'll make that into a mixed number and we'll add that whole number up into our whole number parts. That's what I kind of like to wait and go that way. So let's take a look. Well, let's think about what we know about adding fractions with unlike denominators. So I've got 7/8 plus 3/4. 8 and 4 are not like denominators. They're not the same. So I need to find the same denominator. And right now in my head, I actually have one because I know my facts of 4s and 8s. So I'm actually going to go with my facts of 4s and let's list them out. 4, 8, 12, 15. Oh, sorry, that's 16. Did anything hit you when I said the facts of 4s? Did you notice anything? Take a look. Did you notice this? They have a common denominator of 8. And I don't have to change my 7/8 because it already has the denominator of 8. So let me make my 3/4 into an equivalent fraction that has 8 as the denominator. So to get from 4 to 8, I need to multiply 4 times 2. Whatever I do on the bottom, I have to do on the top. So 3 times 2 gives me 6. So 6/8 is equivalent to 3/4. So let me go back up here, and I'm going to rewrite my problem using that 6/8. So 7/8 plus 6/8. Okay, now let's add these two fractions together. We worked so hard to get the 8 as our denominator, we're going to keep the 8. And now let's add our numerators. 7 plus 6 gives me 13. All right, now I have the fraction 13/8. Do you notice anything about this fraction? My numerator is greater than my denominator. So it's an improper fraction. And so in this situation, I want to make this a proper fraction, which means I'm going to have to turn it into a mixed number. And it's not hard to do that. I'm going to say, well, wait a minute. How many times can I put 8 into 13? Well, 8 times 1 is 8. 8 times 2 is 16. Oh, I can do it one whole time. So I'm going to subtract the 8 that I used for my one whole, which would be like 8/8. So 13 minus 8 is 5. And I'm going to put that over 8. So I have 1 5/8. All right, now I'm not done. I've got to go back up here to my whole numbers, and I'm going to add those, okay? 11 and 2. 11 plus 2 is 13. And then I can't forget about my 1 5/8 over here. I've got the whole number of 1, so I'm going to add that to my 13. Gives me 14. And I got to bring my fraction part up, 5/8. And so now I can answer the question and say that the plant, the second time around he measured it, was 14 5/8 inches tall. Oh, that's supposed to be in inches. It didn't come out very nice, did it? Let's redo it. 14 5/8 inches. There, tall. And that is the answer. Check your work against my work. On your Desmos whiteboard, change anything you need to change so that it looks like mine. If you have any questions, let me know.